Today we are going to see about Prim's algorithm. What is a Prim's algorithm? Prim's algorithm is a greedy algorithm that helps us find the minimum spanning tree for an undirected weighted connected graph. So let us get into the algorithm. So first we maintain a MST set, which is an empty set to keep track of the vertices that are already included in the MST. At the beginning it will be empty. Now we are going to assign the key value to all the vertices as infinity at the beginning. And also we are going to maintain the parent to be null at the beginning. So now when MST set does not include all the vertices, we pick a vertex u that is not in the MST set and has a minimum key value. Now we include that vertex u in the MST set, and then we update the key value of the adjacent vertices of the U and also the parent of the adjacent vertices. So to update the key values, there are a certain condition. First, we find the adjacent vertices V. For every adjacent vertex V, if the weight of the edge UV is less than the previous key value of V, then we update the key value of the weight of UV and the parent of V as U. So if it is not less than, we do not change anything and it remains the same. So now let us try to solve this problem. So this is an undirected weighted connected graph. So the first step is in Prim's algorithm, we can start with any node unless Kruskal's algorithm where we start arranging edges in the minimum value of the edges. Here we just take any random. Now I am choosing A. So from A, which is find a edge with the minimum weight from it. So here if you see A to F has the minimum weight. So now we connect them. Then next A to for A to F we find an edge with the minimum weight, which is F to G. Then we find an adjacent edge with a minimum weight from connecting from the connected components. So from this, CG has the minimum weight. And then from this, FB has the next minimum weight. So the next edge that is connecting these without forming a cycle is GD. So then we connect them. And then we find the next minimum weighted edge, which is D2E. Then we find the next adjacent edge with the minimum weight, which is D2H. So while selecting an adjacent edge, we should make sure that cycles aren't formed. So the final step we have arrived, we would get a minimum spanning tree. So to calculate the total weight, we add the weights of the edges in the final graph. So here the total weight is 19. It is the minimum total weight that can be got from this graph. Thank you all.